Put another hour to go here, and then we can take off for a weekend and relax a bit, more than we get a chance to during the week. I've got up here both the sine law and the cosine law, but what we learned yesterday is the cosine law. I notice, I don't quite know why I did this, but I put a multiplication symbol in the second form of the cosine law between 2bc and cos A. It's usually not written there, but maybe it's just a reminder that it is multiplication that's happening there. The first form of the cosine law, where it says cos of A equals b squared plus c squared minus a squared all over 2bc, is used to find an angle in a triangle when you know all three sides. And the angle you're trying to find is the one that's across from whatever you put as side A. The second form of the cosine law, a squared equals b squared plus c squared minus 2bc cos A, is used to find a missing side when you know two sides and the angle between them. And both the sine law and the cosine law are valid for any triangle. So now let's take a look at the practice problems. Does anybody have any questions you would like me to go over? No? All right, that's fine. We're going to be spending a few minutes here reviewing, and then you'll have the rest of the class to practice some review problems. So this is just a summary of everything we've covered. I gave you a similar handout in the first unit, and I had mentioned at the time that you should keep these organized, so by the time we get to the end of the course, you've got all of them together in a sequential order that's helpful for you. You're welcome. So again, our goal today, we've got a number of items on our plates that we want to work on. One of them is for me to go through this review with you. Then I've got a handout with multiple choice numerical response questions that you can practice to get you ready for the exam on Tuesday. The third thing on your plate, and I've already got a couple of them already, is you can finish up that assignment number 2, which is due Monday, isn't it? Yeah, it's due Monday. All right. This will not take long. I want to give you as much time to practice the math individually. You should know by now that's where you get better and better at stuff. You don't generally get better and better at stuff by listening to me. You have to practice it on your own. So we started off in this unit by talking about rotation angles in what are called standard position. And standard position simply means you take what's called the initial arm, and you make sure that the initial arm is on the positive x-axis. And if the angle is positive, it rotates in a counterclockwise direction. Now, I will tell you right now that even though most of the questions that we've done have positive angles, you should be expected on an exam to understand negative angles. And I'll give you an example of that in a second. So a negative angle is a clockwise rotation. Reference angles, and I really hope this is just second nature to you. I hope that this doesn't require much thought at all. A reference angle, put away your phone please. A reference angle is the angle between the terminal arm and the x-axis with the shortest possible path. It doesn't matter which direction you're talking about. So when you have a rotation angle, which I've given as a red theta in quadrant 1, the reference angle is that same angle. But again, a rotation angle has a direction. A reference angle does not. If it's in quadrant 2, which is in the bottom left corner of your screen, Theta is the angle, well, from the positive x-axis to the terminal arm. You can see what the reference angle looks like there. And the connection between the reference angle and the rotation angle, if the rotation angle terminates in quadrant 2, is that those two angles add up to 180. Whereas the relationship, if we're talking about quadrant 1, is that those two angles are equal. If we're in quadrant 3, you can see what the reference angle is in relation to the rotation angle. And the relationship is that the rotation angle minus the reference angle would give you 180. Or 180 plus the reference angle would give you the rotation. If it's in quadrant 4, then you can take the rotation angle and add it to the reference angle. Can you stop the clicking? Thank you. You can take the rotation angle and add it to the reference angle to get 360. Okay. I told you I would give you a quick example of something with a negative rotation angle. I could very easily on an exam say if theta equals negative 700 degrees, what's the reference angle? And you should be able to figure it out. You should be able to trace it in a clockwise direction from the positive x-axis around 700 degrees and keep track of where you are and where you end up. And I believe you're going to end up in quadrant 4, and I believe the reference angle will be 20 degrees because 720 takes you right back to the positive x-axis. Anyway, you'll see a question similar to that on your review handout or in your review handout. We then graduated beyond working with triangles. Grade 10 trigonometry is all about right-angled triangles. And when you start to look at this rotation angle, there isn't really a triangle associated with that angle. You could make a triangle associated with that angle, but it will not contain the angle. The triangle that's associated with that angle is called the reference triangle, and it's formed by using the reference angle. But we don't need to worry about that because we used that reference triangle to build those definitions that you have on the right-hand side of your screen here, which is that the sine of theta is the y coordinate over r. R is the distance from, I don't have it on here, but this is r, right? R is the distance from the origin to that point. Cosine is x over r and tangent is y over x. We've done lots of questions where you have to do calculations based on the relationship between x, y, and r, x squared plus y squared equals r squared, and those three trigonometric ratios, but we've always had to be very careful about which quadrants we are in. And there's lots of things you can do here, but ultimately those, what do I have, 12 statements? Sine of theta is greater than 0, cos of theta is greater. You need to know all of them. But I don't believe this is a matter of memorization. If I ask you about quadrant, I'm just going to say quadrant 2, for example, and I'm not even going to look at the screen. I'm just going to use, my traditional approach, which is the sternum, the center of my chest is the origin. That means quadrant 2 is up here, to your left and above my sternum. And if I say to you, what is sine in that quadrant, you should be able to figure out that sine of theta is positive because in that quadrant, y is positive and sine is y over r. You should be able to figure out that in quadrant 2, cosine is negative because in that quadrant, x is negative and cosine is x over r. Tangent will be negative as well because tangent is y over x, and if y is positive and x is negative, then positive over negative is negative. You definitely need to work with that for questions that I ask on an exam about sine theta, cos theta, and tan theta. But you also need to work with it for another reason. And that's how to solve a trigonometric equation. So what I'm talking about here, everybody, is if I give you sine of theta equals negative 0.8, and I say find theta where theta lies between 0 and 360 degrees. This is what I'm talking about here. So the first thing you do, well, these two items here, you don't have to do one before the other. You just need to get them both done so you can answer the question. So one of the things you need to do is identify the quadrants in which the rotation angle can exist. And if you look at the example I've made up, I've said sine of theta is negative 0.8. So which two quadrants will sine of theta be negative? Down here in 3 and 4, and if you're watching on video, you can't see my arm gestures, you'll have to figure it out. In quadrant 3 and 4 is where y is negative and y is related to sine. So that's one of the things you do. You say, well, okay, we're dealing with quadrant 3 and 4. The second thing you do is you find the reference angle. When you find the reference angle, you take the inverse trigonometric ratio, in this case it's inverse sine, of the number. If the number is negative, if what the trigonometric ratio is equal to is a negative value, you do not include the negative in your calculator move. So the reference angle, always check to make sure you're in degrees. The reference angle is 53 degrees. So really, everybody, we've learned things. We build these courses in a certain order because you need the stuff that you learn first before you get to the stuff second. So look, you already understand the concept of reference angles and quadrants and rotation angles. Now all you have to do is put together what you've discovered from my equation. I'm going by memory here, but I believe I said the reference angle was 53 degrees, right? In what I just made up. And I said it was quadrants 3 and 4. So you draw a reference angle of 53 degrees. Forget about the fact that that may not be 53 degrees. 53 degrees in quadrant 3, and you figure out what this is, so we would take 180 plus that angle. You draw a reference angle of 53 degrees in quadrant 4, and I know that's nowhere close to 53 degrees, but does it matter? No, because you're simply going to look at it and say 360 minus 53 to get your other rotation angle. So that's what I'm talking about here. Really, in a roundabout way, everything we learned prior to this lesson was learned so we could learn this lesson. There's other reasons too, but and then the cosine law and the sine law, which I feel as though there's really not much I can say. Remember, with the sine law, you can only use the sine law if you know an angle side, what I call an angle side pair. So you need to know an angle and the side across from it to use the sine law. And then what you will also need to know is 1/2 of another angle side pair so you can find the other half. In the cosine law, you either need to know all 3 sides so that you can find an angle with the first form of the cosine law on this screen, or you need to know 2 sides and the angle between them to find the missing side with the second form of the cosine law that's written there. You know, when you break this unit down in terms of content, there's not much content. But the questions can get a little bit messy. That's it. That's all I have to say today to you as a group. I mean, I'll occasionally interrupt what's going on to do stuff up here and to help you out. But I would like you working for the next hour on math. And if you can get an hour of solid math in now, I don't know if I've mentioned this to you. I know I mentioned it to my other classes. You actually have a goal in math every day, other than specific content. And it's that when you leave, you're better at the math than when you walked in. That's a really, really good philosophy. It's like anything. If you go to basketball practice, hopefully you gain a little bit more skill-wise in the practice. If you go to practice every day and you're just flat, then the practice isn't doing anything. So if we put in the practice now, you'll be better at this at the end of today than you were at the beginning of today, but one word of caution. If you go home and you leave your math at the school, you'll be back to where you were yesterday, right? It's like if you miss 3 practices. I'm not saying you lose all your skills, but you'll have to really practice hard to catch up. So use the next hour to practice the review problems, which I'm going to give you now. You also, everybody, of course, have all of the supplemental problems that are at the end of your unit. You also have all of the extra practice. You're welcome. Sections and chapter test at the end of your unit handout. But I know that some of you want to get going on multiple choice numerical response because that's what you're likely to see on an exam. Did I give you this? No. Did I give you items?